if you put it in a sphere, then all the corners touch the faces. Now, only 5 forms in the world do this. That's amazing. So, I want to ask you, is this a Platonic form? Why not? And why wouldn't it?
Well, it won't fit inside the sphere, and the sphere...
Yeah.
That's my instinct, anyway.
That's right.
Won't fit around it.
And not only that, but you have to have all triangles. Oh, that's a square.
Yeah.
So, how is this? This is supposed to be reversing. So I thought, oh, what's reversing? A mirror. So I took a mirror, and I put it on here. Is that a Platonic form? Yeah, it's a mirroring. They were correct. It does reverse. So here it is. Of course, this is the tetrahedron, of the octahedron. Okay, so I took this is my way of trying to approach the 7, because I figure on down the line I'm going to find 7. So I thought, okay, so let's try 5. So I did the same thing with 5. Okay, and I made the 5 table, and the little legs are down there, and I put them together. And let's see if it's going to work this way. Here's another one. I'll put them together. Is that a Platonic form? No, it's not. It has all triangles, but if you put a sphere around here, it won't touch all the points, will it? I mean, you can see that the sphere wouldn't touch this point, and if I put the sphere around here like this, it wouldn't touch this. They all have to touch. So what I realized is have to happen here is that I'd have to add another bunch of triangles about like this, there. And what I saw, if this is, how is this changing, is what happens is when this brings this out like this, it twists. And so it is changing. The others don't do that. There is a twist here that causes this to happen. And of course, these are all 5. They're all 5. 5, 5, 5, 5, 5, everywhere. It's so interesting. All right, so here we come to the last one. Now, if I set these things out here, like here's the tetrahedron, here's the octahedron, so you can see my research. Here's the icosahedron. You can see that they're starting to go down, aren't they? And they go down to the golden proportion, which is really a good number. So, okay, so if I follow my procedure, I would make a 6, right? I went 3, 4, 5, 6. So I take 6 of them, and I put them together, and just like before. And there's 6. And they're all equilateral triangles, of course, just like these. Remember I told you that Platonic forms have to be equilateral triangles, right? But this one is different because it has 6 squares, not 6 triangles. So there's a mystery behind here that somebody challenged me on. And so how do you make 6 triangles into 6 squares? And so, this is flat as a pancake. Look at this. So I went from the highest point, which is why it's called fire, because fire has the sharpest point. It also holds the least amount of volume. Okay, so I said, what am I going to do about that? So what I did was I took the 6, okay, and what I did was I checked root 3 again. See how it is again? The root 3 is between 2 equilateral triangles. Everybody see that? Okay. So you know that this is root 3. Rudolf Steiner called root 3 formative forces. This is formative forces. Okay, so what I decided to do is to work with this. And what I did was I pulled this up into root 3 and it makes a perfect cube. This isn't in the books.
It's not in the book.
It is now the diagonal across corners is root 3. How do you make 6 triangles into 6 squares? That's fantastic. This is unbelievable what's going on in geometry. Okay, so the next thing was, what I would do is make the 7, right? I got 3, 4, 5, 6, 7. Okay, so I did the same thing. I made 7 Q-tips go all the way around, and I put together, and look what happened. I mean, this is ridiculous. But Rudolf Steiner said that 7 was the first number that goes into spiritual work. And what it means is that it's not stable. I mean, it doesn't, if you put a carpet over here and walk across, you're going to go into a hole. Doesn't work. So my procedure that I figured out here doesn't work for me. I worked on it for a long time, but I tell you what, there are things here because I did this that I can use. And I didn't know it at the time. The reason this happens is because see how they don't meet. Hey, the 6 meets, right? And this goes into a pancake, not 7. So that's it. I have to start over. I'm trying to find the 7. All right, so what I did was I took I took 7 of these. I took, let me show you on the computer here what I did. Here's a vesica, of course, that I just showed you in Route 3. Here are the Platonic forms. These are come from, these are 6,000 years old. They come from Stonehenge. They've been dug up. And there was a whole school that studied these because there are hundreds of them found around, and some of them are very beautiful. But you can see that some of them, you know, aren't as good as the others, but these were all found. There is a school that studied these forms. So what I decided to do was I was walking on the river, down by the riverbed, and I said, well, it's time for me to start the 7 in another way. So I took a little bit of mud, and I took 7 sticks on the start of the shore, and I stuck them in a piece of mud. Okay, and so in they go, and I came up with this form. This is the first one I came up with, because this didn't work. Okay, so they're equal distances apart from each other in the same length. So I connected them, which is what I wanted to do, you know, with the triangles. I figured this is the way I'm going to get the 7. Well, the problem is that when I did this, when I got the first part here, I got 10 faces. And you believe that you have 7 points, and you connect them, you have 10 faces? You should have 7. Well, that's what I thought. But so here again, I'm running into this failure. Well, I failed so many times, you can't believe it. So I decided, well, let's see what else. What is history and how they work with 7? Because I had trouble with this. So here's one solution. You take a cube and you cut a corner off at root 2. That's 7. No, that's not 7. 7 to me had to have equal surfaces. So if this was 2 miles square, all the other ones are 2 miles square. That's what I want. I want equal surfaces. Okay, so here's another one. They took this is the cube cut with 1 corner. They just took a block, cut off 5 sides. The top and the bottom is 7. Okay, and so, and then here's a guy who made this. It's just like an ice cream cone with 6 sides cut off, and the bottom is the 7. The only problem is that these aren't equal surface areas, right? And no matter how big I get this, as it goes out and out, it would be about 4 stories high, and that's not a form. You know, it's like an arrow or a stick. So that didn't work. So then I took some spheres, and I put the spheres around a piece of mud, and what I tried to put them together to see what that form would look like in the middle, and sure enough, there's the gap. And here it is. This is the real one, the first one I ever did. And there's a gap there. And the reason that gap is there is because when you push the balls together, the one that goes here and the one on the other side, don't let them get together. So you can't, no matter what you squeeze or whatever, it won't work. So as I have the balls separated, it shows you that what this form is. So I decided after months of failure that the only thing I could do is I have to leave science. I'm a trained artist, okay, and I found out it's much easier to be an artist and find math than it is for a mathematician to find art. Luckily for me, I had the art background. So what I did is I took a ball of clay and I knew where the points were all the way around, so I started to carve holes, volcanoes, okay, into this sphere. And just like on the other things, I ran into the gap. There's a gap again. But artists don't care about gaps. We just keep carving. So the ball, all the curves, turned into edges, straight edges. I kept carving until I got to the middle, and there wasn't anything curved. And here's what that first form looks like. And here it is, the original one. And I carved out, okay, 7 holes. And what's so amazing is that I got 1, 2, 3 with the triangle. And then I turned it this way, I got 3, 1, 2, 3. I turned it this way, I got 4. And that's not quite what I'm looking for, right? But, you know, a couple days later, I realized that 3 and 4 was 7. So that wasn't too bad, it really wasn't. So what I did is, I'll show you where they are. You can see that there's 4 there and 3. Okay, and then what I decided to do is to take hoops like this, small, and I drilled holes in here, put the hoops around, run screws through here, and then I took hula hoops, put the screws in the same places, and I made a big one. And this is the first 7-sided form ever, artistically. This is a subjective 7-sided form, subjective. It's coming off my artistic ability, and this is what it looks like. And you see, I was still influenced. Okay, I was still influenced by this, because I saw this part here. So really starting here to make that really big because it supports the building. I didn't. I could make it small. But also, you see how he has these angles here? See that happening here too? The same kind of angles going on? So I knew I was getting something. Okay. So then I realized I had 42 triangles in this thing. So there's a triangle here. There's one here, there's one here, one here, or 6 there. There's only 3 here, but if you divide this in half, it's also 6, just like this, except it's bent. So I had 42 triangles, so I made the form, and this is what it looked like. And this is bronze. I had it cast because it was such a significant discovery. And I found out that this bar right here could be straightened because these 2 triangles were different than the other ones. So in the process, I found exactly where they were. I took this form. I took 7 cups of plaster of Paris. I poured them one at a time until they dried and took them out. So I had 7 pieces here on the table. When they were dry, I put them all together, and I got the first 7-sided form ever. And it has perfect equal surface areas. And that's what's in the cabinet. Okay, so this was only the start. Once I found it, I had to find out what was inside it, what was outside it, because this form was never here before. It's never been here before. And you have to understand, and I have never seen this. I mean, I didn't see any of this. I didn't see that form. This is what Rudolf Steiner calls sense-free thinking. Didn't use my eyes, didn't use my ears, I didn't use my taste, my whatever. Okay? I use sensory thinking. And that's where we're really free, is in our thinking. So, this 7-sided form, I had to find out what the secrets were behind this. Because this form right here has unbelievable things inside and outside that I had no clue about. Okay, so I went back to my artistic training. That's science. The thing is perfect. It's not even a hair difference between the surfaces. It still has the 4 and the 3. Okay, so I went back to studying my art. I studied and studied and studied. I tried to find out what was going on in this form. And these are all artistic studies to more and more. And then I went back to science, and I found out where the form comes from. And so I drew it engineering drawing, and I made it very accurate. So that what I'm telling you is that I work artistically, and then I work scientifically. And you have to go back between the science and art. That's called spiritual science. Okay, so I found out a whole bunch of things. First off, it would fit into an IQ